Okay, so we are discussing this 0-1 knapsack problem, and we will now be discussing this fractional knapsack problem. Okay, so this fractional knapsack problem, in the 0-1 knapsack problem, what the constraint is that whenever we don't have any remaining capacity, then at that time we cannot take it fractional load. Okay, we cannot take any fractional load whatever item I am having, right, at any point of time. But in this fractional knapsack problem, what we can think of the knapsack problem, maybe the item is more like, say, gold dust, right? So in the previous case it was gold ingot, right? That means gold biscuit we are having, and we cannot break the biscuit, and we cannot take its fraction. But here, if it is gold dust, then I can take some kind of fractional amount, right? So in this case, what we got to do is, in this problem, so to solve the fractional knapsack problem, the algorithm is, we first compute the value per pound, VI by WI ratio. We have to sort the items with VI by WI ratio. VI by WI ratio. With this ratio, we have to sort the items. That means this value per pound, whichever item is with this property, that means maximum value per pound, I will be taking greedily that item. Okay, so that is the greedy solutions here we are proposing. That means value per whichever item is with this maximum, VI by WI maximum, that item I will be taking first. And then this obeying a greedy strategy, the thief begins by taking as much as possible of the item with the greatest value per pound. Okay, so that already we have told. If the supply of that item is exhausted and he can still carry more, he takes as much as possible of the item with the next greatest value per pound. So this, say, V1 by W1 first we are taking, whichever is the maximum. Then in its fullest capacity I have to take this amount, because that will be maximizing my value. After that, if this item is exhausted, say that item only had 10 kg. Okay, so I have taken that 10 kg at max, but my knapsack capacity is 50. So I have taken 10 kg and then still 40 kg remaining. Then how I will be filling up the rest of the 40 kgs? That I will be filling up by going by V2 by W2 ratio. Okay, which is having the second largest value in our algorithm, with the greatest value per pound, second largest value per pound. Okay, and so forth we have to do until he reaches his weight limit W. Until he reaches its weight limit W, that thief will be keep on taking the item that way, right? So what will be the, if this is the algorithm, then can you tell me that what will be the time complexity of this algorithm? Time complexity. What will be the time complexity of this algorithm? Okay, Who will be telling the time complexity of this algorithm? What will be the time complexity of this algorithm? Who will be telling? What we are doing, we are sorting.
It's coming n to the power n, but this doesn't seems time complexity.
No, this is the fractional knapsack I am talking about. And you are having items. You are having n items, right?
N
Like this,
items.
n items, and then that n items you are sorting by vi by wi ratio. Okay. So for each item, first of all, you have to compute this vi by wi for each item. What will be the time complexity of that?
N.
Order of n, because only one arithmetic operation you have to perform. Vi by wi, only one division. So
And then we can sort by n log n.
then we can, so this is taking order of n. Then we can sort it by
And
order of n log n time, right?
n log n.
N log n time. Then each item I will be taking, each item, and then with that capacity, the maximum capacity that as we have already claimed, that the maximum capacity possible for this greatest value per pound, we have to take its fullest limit. So if it is 10 kg, I have to take 10 kg. If it is 20 kgs, I have to take 20 kgs, not going beyond the capacity of this bag. So each item I am taking after sorting, each item I am taking. So I am taking it and I am keeping it here in the bag. And then I have to calculate one more operation, that what is the remaining capacity. So these two operations will be taking how much?
It will
For
be
each item,
pick one.
order of
N.
one time for each item. And
Yes, sir.
likewise, at the worst case, I have to process all the items. So again, order of n time.
N.
So this is order of n again. So this is order of n here. Here we are having order of n, right? And then order of n log n, and then order of n. So the time complexity will be,
N log n.
Tn will be order of n plus order of n log n
Plus order of n.
plus order of n. Okay. So this will be equal to order of n log n.
N log n.
Okay. So order of n log n time complexity, with this order of n log n time complexity, we can solve this fractional knapsack problem. Okay. Fractional knapsack problem, right? So now there is one example is given, that if we go by this is the example. Okay, so this is the knapsack having capacity 50. So knapsack having capacity 50, this is the 50 capacity here. Knapsack having capacity 50. Okay. And we are having these items, right? We are having these items. And you see this, if I am, so this is the fractional knapsack one. This is the fractional knapsack one. So according to this, you see $10 and its WI is 10. So what will be VI by WI? V1 by W1 will be what? That will be 60 by 10, right? So that will be 6. And this will be 100 by 20, that will be 5. This will be 120 by 30, that will be 4. So it is already there in that VI by WI ratio. And in the fractional case, right, so we have to take that first, this one first, and that will be, we have to take to its fullest capacity, that is 10, and the remaining is 20, the remaining is 40, and then I have to take this item 20, so I have to take its fullest capacity because it is not going beyond the remaining capacity 40, and then 30 capacity already filled up, 20 capacity is left, right? So but this item having 30 capacity and the knapsack capacity remaining is 20, so as it is fractional, so I can take 20 kg, say 20 pounds out of that, and 20 by 30 times this 120, that will be coming $80. Okay, so that valuation. So this way we can fill up all the 50 capacity in the knapsack, and its valuation will be 240. So this is the fractional knapsack case, right? Now with that algorithm, if I proceed, then whether this is leading to the optimal solution for this 0-1 knapsack, that is shown here. Okay, right? So this first of all, this 60 by 10, that is 6. With that I am going, so this is 10 I can take, and what is the remaining one? 40, and then the next one I am taking 20, right? Next one I am taking 20. Then next how much is filled up? 30. Okay. And how much is remaining? 50 minus 30, so that is 20 capacity is remaining. And what is the next item? That is 30, right? That is 30, it is shown here. But according to the 0-1 knapsack problem, I cannot take the fraction out of it. Either I have to take 30 units or I cannot take any unit. So as it is 20 unit capacity left, so I cannot take this 30 unit. I have to leave it behind. So you see that if I go by that logic, whatever I have applied in this fractional knapsack, this will not be giving the
Optimal solution.
optimal result in this 0-1
This
knapsack.
case.
In this 0-1 knapsack, right? Okay. But you see that there is one optimal solution here existing. Okay. So if I take 20 for this 0-1 knapsack problem, if I take 20, that means the second item and then the third item, then we can fill the knapsack capacity with its fullest potential, and also this will be giving $220. Okay, so that much may be the maximum possible for this case, and that is achievable. But with that algorithm, if I proceed, then we are not getting that, right? Okay, so today up to this, and the next day maybe we can prove that okay, this greedy choice of knapsack is leading to the optimal solution. Okay, and that we can do with that greedy stays ahead property, right? Okay, so if you have questions, then you can ask me. First of all I have to stop the